G'day guys, back again for another video. We've got a, I don't even know what year this is yet. It's in the car park. I just went out there with my little code reader. We've got an engine light on, Toyota Hilux 3-litre turbo diesel. Had a bunch of issues, had a particular code. They went to their normal mechanic who just read the code and said it needs a new stepper motor. This customer had a mate with the same car and swapped the stepper motor off his car and still exactly the same. So wasn't sure and thought he'd give me a ring and see if we can check it out for him. Just put the original one back on and engine light's on, it's here. Just got my little code reader on here, so we've got a couple codes: turbocharger, boost control position, sensor low circuit, and there you go, same issue for B. So this is just obviously my little handheld code reader. Just thought I'd get it out here. I'm going to go for a drive in it, see how it goes, and then we'll get it inside and get the Verus or one of the scan tools on it and see if we can get any manufacturer specific codes from it and then go from there. Well, that was not very fruitful. This car barely moves at all. I didn't even get out of the driveway, so we're going to go inside and check out what is going on, because we can't even accelerate at all. Let's see what we find. There we go guys, we're on the Verus now, so we've got two boost control position sensor codes. So let's get a wiring diagram and have a look, and then we'll go from there. Alright guys, we've got some service information. So we're looking at the turbocharger variable nozzle sensor. So what we need to do for this code is we need to identify the wires we need to look for and do some wiring integrity checks and some voltage checks and see what we get. So the first step is down here, as you can see, check between these wires, the 4 wires on the plug, make sure we get those 4 to 5 volt signals with the key on. As you can see, I'm on one of them down there now, and as you can see on the U-scope, we've got 5 volts there. I've checked the other one already and they've both got 5 volts. So let's get on to the next test. Alrighty, since all that wiring tested good down at the actual position sensor itself, it wants us to go down to the turbo driver motor that's here behind the glove box. So we're going to check the voltages at both of these, between both of these connectors, and measure the difference. If the difference is great, then obviously we'll decide what to do from there. But as you can see, we're on the first one and we are getting, you probably can't see that, but that is 496 millivolts on the first one. So let's do the second one and see what happens. Alright guys, we're in the other one, and as you can see, it is 496 millivolts as well. So let's go to the next step, and it tells us check the difference between the voltage values. If the voltage difference between VTA1 and VTA2 is within 0.3 of a volt, then okay, then turbo motor driver has failed. So if that was a greater difference, then it would tell us to replace the actual position sensor on the turbo itself, but it looks like the turbo motor driver has failed. So yeah, look, I don't really like these wiring diagrams, but what we might do is I might just do a little bit of digging and see if there's power and grounds we need to check on this motor driver first, just to make sure, and then we'll decide what to do from there. Alright guys, I've checked all the powers and grounds and the computer commands, and it's all passed. I'm not going to show you that because it's a little bit time consuming, and basically what we have here is we have 2 communication wires from the PCM. One's a 12 volt PWM signal and the other one's a 5 volt PWM signal. We've got our main battery power there and we've got our ground there, and they're all good. So this is where we don't like diagnostic flowcharts from the manufacturer, because this tells us that if we go, this tells us that according to our diagnostic flow, that we need to replace the turbo motor driver, so that module right there. Now here lies the problem. So the customer initially had a P0047. Now he was told by another mechanic that he needed to replace the stepper motor, so he got the stepper motor off his friend's Hilux. He swapped them over. His one immediately came up with those 2 codes that we had at the beginning of the video, no longer the P0047, it's now got the low circuit codes. And his friend's car with his initial stepper motor actually ran perfectly. So, you know, from that story, I just wonder, you know, I know these are notorious for harness rubbing along the body or the sump or something like that. So do we have a open circuit somewhere? Now, if we do, and this testing tells us to replace the motor driver, we're in deep trouble. So before we go looking at the actual module, I think the quickest thing we're going to do, because unfortunately we've tested 2 wires on each of these. So if you remember the actual stepper motor unit itself, we checked 2 circuits on it, but there's 2 wires that haven't been checked. So, you know, do we have an open circuit on one of those wires? Is there a wire broken along the way? All right, guys, I've got a spare one here anyway. This just come off a old turbo that we replaced due to failing of this old girl. So luckily I had one. It's not the exact same turbo, but the part numbers are the same. So lucky for me, but regardless, doesn't matter. The testing can still be done on the original one anyway. So what I'm going to do is I'm going to go through all of these wires. So basically we've got 6 wires. We've got 2 5-volt reference wires, we've got 2 grounds, and we've got 2 signal wires. Now the 5-volt reference and the grounds all come directly from the driver module, and the signal obviously comes from the 2 signal wires obviously come from this. So what we're going to do is we're going to go through one by one. So bear with me, I'm going to try and do this with one hand. And yes, I will repair all of this wiring, so don't crap yourself. Now I'm set up a bit better. Hopefully you can see. I'll try and do both at the same time. As you can see, that's our first 5-volt reference. We've got a 5-volt reference. Okay, the next one is a ground. Sorry. And as you can see, we've got a good ground. We've got that noisy signal, and we've got no voltage drop there. Perfect. Next one is, what we'll do is we'll do all the powers and grounds first. So this blue one, oh no, hang on 2 seconds. No, that blue one's a ground. So as you can see, we've got a ground there. We have got a, sorry, we got a 5-volt reference there. Now let's do the two signal position wires. So as we can see, we've got a position there. I move the sensor and we get a reading. So let's go to the other one, which is the green one. If I can get in there with one hand, so excuse me. There we are, right there. So let's try that again. That's not dropping out, I've just got a poor connection there. So as you can see, that's working perfectly. So because we get the ground and the power from the driver module and the signal goes back, we know the power and the ground coming out of the module are good. We want to go back to the module in the car, and we're going to do the green wire and the red wire to make sure that this signal is making it back to the module. So let's go ahead and do that. We're back inside the car, so we're going to do this side of it to make sure we're getting our signal down to the driver module. So I'm going to do the green wire first, and then we'll come back and do the red wire. Now we're on the inside on the green wire, so I'm just going to move the position sensor, and then we'll see if we get a reading over there. Now as you can see, that is making it all the way to the driver module. So let's go and do the red one. Okay, now we're on the red wire, so let's try it again. And as you can see, we are getting a reading down there. So it looks like we might need a new turbo driver module. We'll come back to you. I was a little bit worried and not 100% sure. Didn't really want to call it straight away. One of my guys actually drives a KUN26 Hilux, so lucky, it's 1 bolt. Put his turbo motor driver in there, and guess what? No fix, code's still exactly the same. So where are we at with this car now? Well, there's really nothing left in the system. We've checked the wiring, we've checked the connectors, we've replaced the turbo driver module. The only thing that is left is the stepper motor assembly. So, because I've got my guy's car here, I'm very, very lucky actually. We're just going to take his stepper motor off and plug it in and see what happens. At the end of the day, that's the only thing left, other than the PCM and the two, communication wires to the turbo driver module, which is highly unlikely. So that's where we're at. This is a bit of a headache, this one, partly because of what has been done before it got to us. We don't really know what's going on. Like I said, the original code was P0. I don't know if I said this at the start of the video, but the code when he went to his mechanic to start with, it was P0047. And then once replacing or swapping over whatever they swapped over, it came up with the two latest codes. So let's just swap that over and see what happens. Okay, this is where we're at. So obviously, sorry about that last graphic, I just had to put that in because I ended up taking a photo instead of recording on that one. But as you can see, it looks like the customer, when he pulled the stepper motor off, actually pulled the back of that 10mm off and put it in the wrong spot after, and basically ruined the stepper motor. So what we've done is we've got this other stepper motor on there. We've plugged the old module back in, so basically it is in the exact same condition which it went to the first mechanic in with the P0047. That's what should have been there. So let's just go see with the new stepper motor on and the original, the donor stepper module and the original module, turbo driver module down here. Let's see what happens with the codes. Here we go. As you can see, we've got our orange one on. Let's go for trouble codes. And sorry for the glare, but look what's back. P0047, which is the original code that it was in for. So what does that tell us? That tells us that our stepper motor is good, our position sensor is good, all of our wiring is good from our integrity checks before. The only thing that is different is the module. The module is the original module. That's the only thing that hasn't been changed. So how about we go out and put the donor module back in and then see what happens. Actually, I'll just take you over there now. I'll keep this going continuously. Take me 2 seconds to just throw this on, as long as I can get my hand in there. The connector's a little bit tight. She's in there. Let me get that. That's a no good there. Let's go over. Oh, can you hear the chatter of the stepper motor already? Let's just clear these DTCs and see if they come back. Yes. No fault codes detected, so let's just go back out, because they usually come back straight away if there's an issue. Trouble codes. One more time for good luck. There you go. So, as you can see guys, that is where we're at. So basically the whole time, from the initial fault, the only thing it ever needed was the turbo driver module. So unfortunately this is, this was a bit of shambles going on. Obviously the customer wanted to attack it himself, and obviously we were told that he swapped the stepper motor over with his mate's car, and his mate's car ran good. So unfortunately we took that at face value, and we started attacking the electronic codes, the circuit load codes, which obviously were related to the boost sensor. So following the Toyota diagnostic flow chart, it told us to replace the turbo driver module for that code, but as you can see, to repair that code, it actually needed the new stepper motor, because there must have been a correlation issue between whatever the stepper motor position it was in and the actual position sensor was registering it in. So yeah, obviously those Toyota diagnostic charts, they can't account for everything, I guess. So got to take that with a grain of salt whenever you're following those charts anyway. But you know, we did the whole bunch of testing, and yes, if we knew about the starter motor being disassembled, this probably would have gone totally different, totally different way. So at the end of the day, you live and you learn. We do our best to get the right information from the customers, but we can only go by what we're told. And you know, sometimes we're always taught to forget about what we're told and just start from scratch, and sometimes that's what we have to do. But this is the way that this one panned out. Hopefully you saw some tests involved and that made some sense that you can apply to any of these codes. And yeah, what I'll do now is I'll just go for a drive in it to make sure 100%, but it's clear there's going to be no issue here. We did take that stepper motor off and the vanes do move on the turbo, so I'm confident this is going to be completely fine now. But I'll definitely try it and I'll come back to you. Okay, road test is done. We have our boost back. As you can see, no engine light on, no trouble codes again. So there we go, that's where that's at. Thanks for watching, guys. I hope you see that it's really important to get the car diagnosed right. Obviously if you're a mechanic or a tech watching this and then you know that's exactly how it should be. But if you're not and you're looking to get your car diagnosed somewhere, it's important to get the diagnosis done right. Unfortunately, this is going to cost the customer a lot more than what it would have been if it was just a module. Now it's cost them a stepper motor assembly, a module assembly, and a whole bunch of diagnostic time that might have been avoided in the first place. So I hope you got something from this, anyone that's watching, and if you found this useful, and please like and subscribe if you haven't already. Thank you so much.